we may have a larger way to keep a watch on what is going around. But then if you are looking at the internet, then it's available for anyone, then it becomes difficult for a monitoring. And of course there is monitoring and control, but the level is much different when we move to the internet and in the local. And in the cloud, there could be data hosted there, there might be applications running there. The applications may be accessed from a cloud hosted application via your browser, or it could be some mobile application that is accessing. Those are the kind of systems where we will be talking. So all what we are talking here, any point here is susceptible to vulnerabilities. Like say all the things, the devices could have vulnerabilities in that. The communication, there may be routers, or there could be other communication points, like you typically at home you may have a Wi-Fi router that is available, could have vulnerabilities. And it could be in the edge gateway, that is physical devices. And the cloud applications or the cloud infrastructure on which you host the application, the infrastructure may have vulnerabilities. And the VMs that are running there, all those kind of things could have issues. Or even the application themselves, or even the devices which access the application, like your mobile, they also may have a vulnerability. So it can be anywhere in any of these kind of place. So today's discussion is not limited to vulnerabilities found in one place. It could be in any of them. It could be in the physical devices, could be in the hardware, the firmware, the software applications. Any of them could be vulnerable points. And if you look at vulnerabilities on a much more simplistic manner, they are typically defects in the software. Defects, it's not that it is not performing the function it is supposed to do, but it is also that the system is not allowing adversary to exploit the system and to take actions and take control of the system by an adversary. That means we are not robust enough to protect the system from other external security malicious actors. That is, there are typically defects in the software which can be exploited by this kind of somebody with a malicious intent. And that exploitation can affect the confidentiality, integrity, or the availability of the system. See, when that happens, we call that, okay, there is a vulnerability. So in the previous architecture diagram, any of that components that we saw, if an adversary can come in and if they can maliciously act on the system to affect the any of those security properties that we described, then that's a vulnerability. Like say, for example, only authenticated users can access certain data. And if you are allowing a user without an authentication to access the data, that means not a genuine actor on the system, not a genuine user also could access the data. So that means there is a problem. Say there is a buffer overflow, so that allows remote command execution that can happen in the products. Then that's because an adversary should not be able to uh, work on the system where they are not allowed. That should not happen. So if you really want to look at these kind of vulnerabilities and what is kind of threats and classifications, there are various models for that. And some of them we call it as your spoofing, tampering, repudiation, information disclosure, denial of privilege, denial of service, elevation of privilege. All those are the kind of typical vulnerabilities, the effect that can happen. Okay. So that is the usual, again, the way industry classifies what kind of vulnerability it is. So that is the kind of issues that we are talking about as a vulnerability. And then go further, there is the concept of threat, vulnerability, and the risk or an incident that is coming in. What we talked about till now was about vulnerability. That means your product has a problem. There is a issue, there is a software bugs, there is a defect that an adversary can exploit. Threat is more about the adversaries themselves, like what are the environmental or who are the negative actors or the malicious actors who are there. That are the threats. Say if you look at somebody who is living in a isolated island where there is nothing, there is no wolf around, okay, there is no bad people around, all are good. If it is a heavenly place, then okay, there is no threat actors there. If there is no threat actors, then vulnerability in itself is not a problem. You go and you sleep under the sun like that. It is like, okay, there is nobody who is going to come and eat you up. So if that is the kind of situation that we are talking, the threat is not present. that, okay, the vulnerability, even though it is present, it is still not an exploitable item. Whereas if, but if that is not a realistic scenario, the threat actors are always there, uh, especially in this cybersecurity world or the security world, and where these devices are there. Uh, Threat actors always exist, and then that is where we try to reduce the vulnerability part, or we try to manage the vulnerability, because that's what is there in our control. But if you are going on looking at the threat actors, we are not able to, like it is not practically possible to come down and bring down that there is no threat at all present in the environment, because we have to make these applications useful. So it's not like you can keep it locked or anything under without use of being any interface open or exposed or useful. See, then the system is also not useful. See, that's not the way that it will work. So threat actors are there, so they are not going to disappear anywhere. So these vulnerabilities are the ones which could be exploited by the threat actors, and then they could, that poses a risk to the system. So that is where we call that when there is a threat and vulnerability together, that poses a risk. And when we call that incident, even if a risk exists, we call that an incident when something is actually happening. So with the threat actors and the vulnerability in the environment, risk exists. And if anyone is actually exploiting the system, say somebody is stealing your password, somebody is stealing your data, someone is bringing down the system, if any such event happens, that is when we call that as an incident. So these are the basic terminology to understand. There is threat, which we don't assume they don't exist, they always exist. There is vulnerability that we can control. It is flows in our own product, our own design, which we can control, manage, reduce. And when both of them exist, that is a risk. And if there is something that actually happens, then that is a security. Okay. So you might be seeing, like, there are a lot of systems running in the world, and all of them have certain levels of vulnerabilities and certain levels of threat that is existing. But then we see suddenly news in the world that, okay, the system was affected, there was a ransomware incident, when that existing risk was being exploited, and when an incident happens, that is when uh, where some threat actor has come in and has started to act on your system. I hope these terminologies are clear now. And today's focus is not on the risk management or the threat actors or incidents, it's about the vulnerabilities. And how do we solve these vulnerabilities? So how to provide this solving the vulnerabilities, they can be solved only by the people who are really designing the system, who are the owners of, like, say for example, if we are running a Microsoft Windows, it's it's Microsoft who can solve vulnerabilities which are there in that. It's not anyone else who can solve it. So once the solution is available, it is up to everyone to go and apply those solutions, and the patch management which Mohan sir was telling in the beginning. So it is up to the every users to apply that. So even if a solution is available, if you have not done the update to the system, and if you have done the corrections, then it has not taken effect. So the cycle has to be completed. So that is what we are seeing here. What I put there is the major cycle from a product vendor's point of view. How do you do this kind of vulnerability management? The first point which we are talking about is someone discovers a vulnerability. So how do someone discover the vulnerability? Because running systems are there, systems which are deployed, and our assumption is that no system is 100% secure. There is something that could be residual vulnerability or residual risks that are existing. So finding out and discovering the vulnerability is the first step where this vulnerability management starts. And how these are understood, it could be by users of the system. They may be finding out something, like if you and me find out some kind of a Windows vulnerability and report it back to Microsoft, that is one way of finding it out. And the other one could be the product companies themselves, the product owners themselves. They will be continuously running scanners, they will be testing the system for known vulnerabilities, or are there programming patterns that disclose certain vulnerabilities. And like there are databases which shares the common weakness enumeration, that is CWE, which database says that, okay, these are the typical ways in which programmers or make mistake. These are the commonly made mistakes of, that's why we call it common weakness enumeration. They are programming weaknesses that can happen. And then if there are such weaknesses existing or not, by means of code reviews, used by testing, analysis, all that. The owners of the system or the developers of the system themselves will be trying to find out whether there is any issue or not, or any vulnerabilities are coming out in the components used in the larger product, like could be open source or it could be other even closed source components. So they could be there monitoring continuously. So that is another way of finding out vulnerability. And one another thing which many organizations have made it systematic now is about the bug bounty programs, which many of you might have heard. Bug bounty programs where the idea behind the bug bounty program is to identify whether there are vulnerabilities in the system. So these bug hunters or these kind of bug bounty researchers could find out. They spend some time, analyze the system, and then find out whether there is any issue, and they report it back in a responsible manner to the original owners of the system, so that they can fix the issues. So those kind of programs also are vulnerabilities are discovered. So once it is discovered, the next step is in analyzing and resolving. That is about finding out the solution. There are multiple substeps that will be involved, where all it is affected, and what is the root cause. Is it fixed systematically? So those are all the multiple sub steps that will happen in the analysis and resolution. And once the analysis and resolution is completed, they are published for the larger audience for consuming that solution. So that is where, say Microsoft, for example, they have this Patch Tuesday, Patch Wednesdays, which they call, where those patches are published. And once the solutions are published, that publication happens so that everybody can take those updates and then update your system, and so that you are running without vulnerabilities. But the timing also is important here. First the solution is available, then you publish it, because the moment you publish that, okay, there is a security vulnerability in the system, that public data is available not only for the positively intended people, they are also available for the adversaries. So it is never that you say that, okay, there is an issue in the system without having a solution already available. You publish it only with a solution available, so that that's what is a responsible behavior, because those who are genuinely using the system has a solution and they can update. Otherwise you are put into a situation where the genuine users, they know that there is a problem, but then solution is not available. So that is as good as giving a weapon in the adversary's hands. So you only publish it after you have a solution available, cleanly tested, everything available, then only you put it into the public domain. And there are databases where all these are published. One place is the NVD database. NVD database contains the known vulnerabilities in products, which we will have a look after some time. So there you can go and see what are the known vulnerabilities in the products, which available, known, all that are. There is a process in which this NVD publishes and manages that also. Uh, with like that, that's all coordinated ways of putting it outside in the public domain, that okay, this vulnerability is there, so please update your system so that it is no more under the security risk is reduced because you have updated the corrections. And if you are not able to find, there are also situations where it may take time to analyze and resolve the issue. If that kind of an issue, and if the vulnerability in itself is known to the public, and if the solution is not yet available, then there are also cases where you provide some kind of a mitigation action, even though it is not a final solution. How do you contain that for the time being, whether it is by having additional firewall rules, or it could be disconnect the system from, say, internet, and you work locally for some time till you have a solution. So those are things which you call as a mitigation action, so that you don't allow for the adversary a reachability to the areas where it is exploitable. So this is all about reducing the risk in the system. So this is how the vulnerability solution happens. So it's typically like if you look at it from a software developer's point of view, one issue was there which is related to security, and you provide a solution for it, and you make the solution known to the people who are the affected parties because of that issue that is existing. And when we say publish, it means that they are also published into the NVD or the CVE database, so that it is known to the public. It's made public. Okay, see, here is one another case which I was talking about, the 0-day. In a 0-day happens, what happens is that a vulnerability is discovered, so the adversaries can exploit the vulnerabilities, and then the cyber criminals, they can uh, exploit the issues, and the issue is discovered by the software vendors after when it is known to the adversaries. So this is a very dangerous situation. So 0 days are something which we should avoid. So the thing is, the people who are responsible for fixing the issue and providing the solution, they are not aware that there is an issue existing in this world, but then it is known to the adversaries that there is an issue that is existing. See, that is where the 0 days come in. So they get a window of time where the system is exploitable, but solution is not available. It is not known to the software vendor or the product vendor. There is, so because it is not known or there is no fix is available immediately, but then it is open in the world and it can be exploited. So that is where the term 0 days coming. It means that there is days to fix the issue because it's already known. So these kind of like if you look up internet, you will see these kind of terms like 0 days very commonly. But that 0 days should not happen. That's also our aim. Like previously, I was telling about the timing. Like it should not become public before the vendor has fixed it and they have the solution available. And then we talk about patch management. This is what Mohan sir was telling in the beginning also. Like when you say patch management, the assumption is that the product team or the product vendor or the software vendor has fixed the issue, but then now we have a solution available. Now we have to update it into the system, into the running system. Say if you are, for example, if you are running your Android mobile, you get a patch, you get a notification, and then you update it. So how can we go ahead and update it? What if I'm doing some other work at that time and I don't want to update? I'm in the middle of something and I don't want to. And that same concept when we are talking about for systems which are critical, a critical infrastructure that is running, you cannot afford to bring down the system at your will and wish every time to update your patches. So patch update is important, security patch update is important, but the system's primary functionality, where the availability of the system is important. Say it could be critical, safety critical control system that you are running, or if you are having, say, kind of a danger warning system, say a tsunami warning system for an example. Okay, see, you will not want to bring down the system for the patch management. Instead, it has to go through proper maintenance cycle. So when there is a maintenance cycle, maybe you may have a redundant system, or you will have some way to manage that the primary functionality is not affected. And only when you are able to get windows of time where the primary functionality is still intact, either by redundant system or by a notification to the public, like say if you look at IEEE and all, sometimes when you try to log in, you see that okay, the system is under maintenance. Maintenance doesn't always mean security updates, but a maintenance window could also be used for doing the security updates that happens. So that is the challenge for the system operators or the people who are running those websites or running those system, running those devices, that okay, I know that there is a issue, I know that there is a solution available, but can I update it right now? It may not be possible. So that is where patch management becomes a bigger challenge. First is about knowing the patches. That in itself is a challenge. Like, okay, whether there is any security patches which are of high critical, high severity, which has to be updated here. Usually the product vendors will give notification that, okay, this has to be updated. But that is all only for high critical issue. Otherwise, it will be published into the NVD database. Or one more thing, that many responsible organizations will have their own website where they for the product owned by them. These are the kind of security issues that are there on our products. So you could look at these security issues and update. So responsible organizations maintain their own websites and then say that okay, this is where you can see if you have any concerns on the patches. And usually they also give kind of reach out to how to reach out, whom to reach out in case of there are issues on security and all that. So once you get to know all that, how do we update that patches? So that could be coming from various sources, and that could be on in-house developed components itself. Like say, so software component developed by us, it could be the issues that are there, or it may be coming from open source software components. Nowadays, a lot of products have many open source components available in that, like your OpenSSL libraries. uh, or even some kind of like many open source components. Like OpenSSL is a very good examples which are used for the security functionalities, or it could be from third-party libraries. Like it may be paid components, may not be open source, but still it is in the component provided by some other. Like say the same Windows example which I was talking about, we are all using making our system depending on Windows, and then they themselves may have a vulnerability in that. May not be in the application developed by us on top of Windows, but if the application also can become affected if the underlying operating system has an issue. So that could also be a case. You must have heard of issues which like heartbleed and all that, which has come where they're at a chip level vulnerability. So how do you do that update? Like it can't be that suddenly you take in an update, the solution has to be available, then you have to do an update via the operating system. All that has to happen. So yeah, some of them could be in the commercial applications also. Like we generally take applications, install and use it as it is, like your Office or these kind of calls, or there are things which you just take it, download, install, and then use it. That kind of commercial applications, they also could be the ones which are containing those vulnerabilities. So there is a difference in the patch management that we will be doing in all of this, because some of them we may not get notification because they are open source components. So you'll have to keep a watch and then understand that. Whereas if it is product which are bought and then or in-house developed and all that, then we have better control over that. And that is where the difference in management is there in the cycles which happen in all of these. And how do we come to know of all this? There are also tools that will help to understand and identify. Like some tools are like they you typically call them a software composition analysis. They serve two purposes. One is they also understand and identify. If you give a build to a software, it will analyze and will understand what are the individual software components and libraries containing in that. One tool which is very popularly used is black tech, that identifies what are the software components available. There are many tools there. They are typically known as software composition analysis tools. And there are also scanners like Nessus scanners or your Nexpo scanners. There are so many, the Kali Linux kind of tools, like which many of your student community might be familiar with that. Those tools might be there. So they can also find out whether there are any known vulnerabilities. And there will be also continuous monitoring for any kind of announcements that happens via the CVD database. All those are another ways in which you can understand that there are vulnerabilities and patch management that has to happen. So ultimately what happens is you get to know about these patches, identify the window of time where you can afford to do these patch updates, and then do this patch update, test it, make it clear that the system is still working, because sometimes what can happen is once you apply the patch, it will stop working, or maybe the functionality may be affected. So that's also important. So after applying the patch, you will have to retest, make sure that it is still working, and then deploy the system. See, that is what happens in the patch lifecycle. And I also told about the term called a bill of material. Like bill of material is something which helps in understanding what are the kind of software components that has gone into the system. Like I told just before, the numerous kinds of software modules that are there, it could be open source. But then in that, how do we know which version of the software library, like OpenSSL, for example, which version of the software library is used? Does that version contain a vulnerability? Because if there is a particular version which has a vulnerability, it's typical that the vendors or the providers will fix it. So you should also know which version you are running to know whether that version contains a vulnerability or not. So if you look at the construction of a software, it has a tree structure that can happen in the construction. Like typically when you build an application, you will have one software module, another software module, and multiple modules then will create, say, for example, module 5 is created by making use of module 1 and module 2, plus some more of fresh developed modules. And there may be another module coming in from, could be from other closed source or paid modules which are coming in, and ultimately you create an application and you are running that application. So to know whether this particular application contain a vulnerability, then we need to know what is the software components that has gone into it, that, and whether any one of the software components has a known vulnerability in that. And to know that, we also need to know which is the version of individual components that has gone in. So this is where the software bill of material come into picture. So by knowing this, bill of material, that is one way where you can know whether your software contains, like for example, if I am developing a application making use of time, say, or if I may be making use of say OpenSSL library, I may be making use of various other things, and it could be so happening that the OpenSSL library I'm using has a vulnerability. So first of all, I should be knowing that okay, my built application contains what all modules. It may appear to be simplistic, but it's not that simple, because when you create large applications, there will be numerous components that will come into it. There's a question on, madam, how to test the third-party patch software component without affecting the regular day-to-day. See, there is no guarantee that regular day-to-day functions will not be affected if you are testing it. And it is also not possible that on a running live system, you don't run test for securities on a live running system. No, that's not the way to do. You should test it on system where you can afford to do the test. Because you cannot affect the primary functionality of the system by running security scan and security test. In a larger installed system or critical system, you don't do that. You will test it on a standalone test system, find out what issues are there, then you plan for an update of your primary system in a controlled window, maintenance window, you update it. That's what you do. Like it's not a good practice, or like people don't do that. You don't run security test on a live running system. That's not the way it is done. Okay, let us come back to the bill of material. So this is the way this bill of material could help you to identify what are the components, what are the issues which are there, which version you are running, and based on that version, is there an issue? Because I may be running a version which has a vulnerability, or I may be running a version which does not have any vulnerability, and all those are fixed. Issues are fixed. So that is all things which need to be taken care. And this is a recent, it's not a recent development in that sense. There's a lot of attention that is coming on this bill of material in the recent past. Like various organizations are moving towards managing this bill of material. Like implicitly, this management was happening all the time, but now this is a very much talked about subject on managing the bill of material, because that is a way where you can know for sure that whether this version, this specific component has issues. Let us continue. Now I had told that I will talk about a scoring system. This scoring system is how do we know that when we talk about a security issue, how severe that issue is? Some people say it is a critical issue, high, low. Like some of the questions which were there was like, how do we know that the issue was reported by any of the scanners like NSS and all that? When that happens, can we make out that okay, what is the severity of that, how important it is, how much urgency I should give for attending to that? All those are defined by the way you call it as the criticality of the issue. That criticality is defined they are standardized numbers from 0 to 10. Based on that number, you say that okay, how critical that issue is. That's what the severity is identified based on a number. That's what the scoring system. This scoring system is used industry wide. It's yeah, uniformly, so that everyone uniformly understand how critical that issue is, what is the severity. And this scoring system is maintained by a group called Forum for Incident Response and Security Teams. So that is what you call as a first. You could try to go and have a look at first.org. That is a place where all this kind of information is available. Like various companies are participating into this first.org, and then they are the one who are defining and then make scoring system. So the scoring system also go through revisions based on what is the need of the industry and how it is seen as a the severity. Like sometimes the severity, the method in which you assess the severity also gets revised based on how the industry sees the severity of the issue. There is a new revision that is there now, which is under review. If you look at that, the new revision is looking at, they are also considering safety as a security issue. Okay, like safety from the point of view of security, that such kind of items are also considered in the new revision. The new revision is not yet being used. So we will look at this, what is currently used. Okay, so when you are scoring, the items that are considered for the scoring system. There is a base metric which you will find out, and there is also temporal and an environmental metrics. We will talk about temporal metrics because temporal and environmental metrics are varying, because temporal is like as the time progresses, maybe you will have variations in how you see the severity because the solution may be already available, or there might be an exploit code that is already available. If an exploit is available, you don't need too much of an expertise to exploit the system. If an adversaries have created or somebody has created exploit code and has published it, with somebody without too high competence or expertise can also exploit the system. That means it becomes more of an issue. But if a solution is available and if it is automatically updated, and if uh, updates are easily available and it can be updated, then you are not talking about it. It's no more. The reduce it comes down. So that is the time based metrics that are available. That is the maturity of the exploit code, and the remediation level, is it available, the remedies are available. Similarly, the environment metrics also are something which is based on the environment in which it is deployed. So it's the based on where you are using the system or how the system is exposed, you may have a variety. So we will not look at the temporal and environmental today because that keeps changing, whereas the base metrics, they remain. In fact, the CVD, when they publish, they are publishing the base metrics. In the base metrics, we look at two parameters. One is the exploitability metrics, and another is the impact metrics and the scope. So if you look at the exploitability, it is talking about how easy it is to exploit the system. That is where you see the attack vector, attack complexity, what privilege you require. Do you need the user interaction of another user other than the attacking person to get to exploit the system? And see privileges required. For example, somebody is asking, do we get certificate? One of you should answer. Yeah. Like what privilege you need. If you don't need any privilege, anybody can exploit the system. That is a bigger danger. Or it could be that you get login with a lower privilege and you can do your privilege escalation and then get admin rights. You log in as a normal user, but then you can do privilege escalation, get higher rights like admin, and then you can exploit the system. That is another way. And this attack vector, attacks complexity, do we have to be physically near to the system, or can I exploit it from a remote environment? So that means over the internet, can you come and exploit the system, or should you be physically close to the system? That is other kind of considerations for this exploitability metrics. And if you are talking about the impact metrics, like initially the first itself I told about security is about confidentiality, integrity, and availability. So what is confidentiality, integrity, and availability? That is what we call as the impact metrics. So considering all this, there is a rubrics that is put in by that first.org. So based on that rubrics, you will get a number between this 0 to 10. 0 means okay, it's not a vulnerability. You will get to 0 if you have a confidentiality, integrity, availability score of 0. That means the system is impact is 0. If the impact is 0, okay, then there is no issue at all. There might be functional issues, but it's not a security issue, not exploitable. Okay. And the scope is a different dimension to it. A scope is like, say, if there is a vulnerability existing in one system, can you exploit that system alone? Or by making use of that vulnerability, can you exploit the nearby systems also? It could also be possible that the affected system and the exploited system could be different. You can go beyond, and then you can go further beyond your vulnerable system and exploit further nearby system. If that is the case, dangerous. So those are the considerations that are looking at into this base metrics. Based on all this, you come to your severity of the vulnerability. Okay, and based on those severity, there is also a number, and along with the number, there is also a qualitative rating, so that we get a feel of how it is. The qualitative rating is, if it is 0, it is none. Low severity, we call it if it is from less than 3, and up to 3, that is what we call as a low severity. And if the criticality is say 9 to 10, then it is a critical severity for the vulnerability. And similarly, we have medium. Medium is like say up to 6.9. So any vulnerability that we call as a high severity or a critical severity, like, okay, that is where you prioritize those items to fix. So like you should fix them on like that is all you can use on how to prioritize. What should I look at first? Which one should I be focusing on first? See, for example, we told before that, okay, we don't want to uh, uh, the system in itself, it may be a running system, so we want maintenance window. Should it be done now, or can I wait till the next maintenance window to do the update? Such kind of prioritization and planning can happen based on all these kind of inputs that we have. And then after getting all these, you will get, there is a score, as well as this score is a 9.8 score which we are talking, as well as a vector representation, which I told before. If you look at this, you have this attack vector, complexity, privileges, interaction, all these are the parameters, and they are represented as a vector. Say a CVSS 3.1, that is a version of the scoring system used. And then you have availability, impact, uh, confidential kind of items are taken, and then you have you see, this is your confidentiality, availability, integrity at the last ones. These are your first one, the attack based item, and this is your impact based items. So this is your attack vector, attack complexity, what privilege you require, all those. So you will get a vector representation. So the vector string is telling everybody can understand what it means in a very uniform manner, because it is so possible that various vector representation can give you the number alone, the score. The number is an indication from this is also a detail. From the detail, you know, okay, like maybe I'll show you some examples. That would be easier. Okay, we'll come further. So you get a string. Once you understand the vector string, you know that, okay, this is what is the severity of the issue and why the severity is so much. That's also you understand the reasoning. So the metrics, you come to the CVSS score and the vector string. There is a tool that you, there are various tools available in the internet, but use the one on the first.org website itself. So you put these base metrics, and they get into that equation for apply those rubrics of all these exploit parameters and impact parameters. And from that, you will get a score as well as a vector string. You will get both of them. Okay, let me try to show you. That would be easier for a better understanding. Okay, see, I'm showing this tool from the CVSS website itself. I hope this is still visible, the screen which I'm showing from first.org.
Yeah.
Okay, so here, see, you can put scorings here. Say, if you say it is a network-based attack, or you need to be an adjacent system, or you should be local, or it is a physical attack, all that you are talking, say a network-based attack. Say what is the complexity required? That is it a high complexity required or a low complexity? Let us put a high complexity. And privilege, say I don't need any privilege for attacking. And do you need the interaction of any other user? Say, let us say, no, I don't need any other interaction of any other user. These are all getting into higher severities. Okay. And then scope. Scope means, is it only this system that can be exploited or something nearby? So it is unchanged, means only the affected system, the vulnerable system is exploitable. And confidentiality, say there is no impact on confidentiality. Say integrity is a high impact. Availability is a high impact. I'm just putting it for a some sample score. Okay, so you will get a score of 7.4, which is a high severity, and as well as you will get a vector string. So once you get these two details, that tells how it is. Okay, so now let us see if, for example, if the scope is changed, that means you can exploit the current system as well as other nearby system. If that's what you are changed, if you put, it becomes still higher. So these are the kind of scoring that happens. And say you let us come to the attack vector. If it is a local attack, it is not a network based, then it becomes, the severity comes down because it is more difficult, because somebody cannot sit far away place and then exploit your system. That is where you call a network based attack. So like this, if you keep doing this, understanding, but the thing is, it's not about the numbers. You should understand what exactly is required, that the design of the system, or the ones who are architecting or the designing the system, they will know what is the requirement, what is the impact of that vulnerability, and how it can be exploited, how it can be attacked. That is known. Say the complexity. You don't need too much of a complexity to attack. A low complexity is enough. Means you don't need high expertise. Complexity is not only about expertise. It's like how much difficult it is. Like step one, step two, step three, or you may have to go and find out some more information from some other source and then make use of that to put together both of that and then come and attack your system. That is where you call it high complexity. If the complexity is low, you will get into say 10, it has already become high. So these are the kind of scoring the tool that we are using and we are talking about. Okay. And let's see some more examples of what we are showing. I put some samples. Okay. So this is the calculator which I showed. And then for a samples, let us look at some NVD database samples which are available. Yeah, this I'll bring it on table for you. This issue, what we are talking was the one which was so much there in the news a while ago, maybe an year or two ago. That was the one log4j vulnerabilities, which had a very high severity. I think it was about 9 point or 10 itself is put critical. Okay. So here, these kind of issues, these are samples. This is a database which I was talking where you can go and look at all the published vulnerabilities. All I don't say, but most of them are getting published into the NVD database. That is what is the master list that you can refer to. So they publish the description, severity, and why that is. You see the base score as well as the vector string, how it is coming in. So if you look at the vector string, there is a description of what it is, okay, that you can look at. And they also provide references on where the solution is available, if there is any tools available, any advisories the product companies have put in. All those kind of information are published on the NVD database here. This one has lots of information because that at that moment was a news item among the security communities. So that is where you will see this. And if there are any products which are affected, all those kind of information are also put in here. So you can go to NVD database and understand what are the issues that are there. Then let us look at one more. Some of them. This is about, I believe this is OpenSSL. So this is not that high critical. This is high, not critical. The severity is high, and this is the scoring, the vector string that is available, which you can look at, and those kind of information is available. So if anybody is interested in understanding the CVEs and the scoring system in a better manner, the places to go to are one is the first.org's scoring tool, and there is also a tutorial available on how to look at these parameters. There is explanation available, so you can look at this first.org's tutorial and understand how that scoring system is done. Uh, like as I was telling, this is not a one company or one place. This is how it is done in the industry. A standardized method of scoring so that everyone understand it in a uniform manner. So this is the place where you can go and find out more. And the new version 4.0 calculator is there, but this is not yet adopted under review. This is it's under public preview. So people can see and give feedback if there is something that has to be given. And I believe there is also a training course which you can take on CVSS scoring. It's a free course. You can go and self-register and take that course. They'll give you a certificate also if you finish that course and answer their questions. So this is one thing which, if somebody is interested in knowing in detail, I would recommend that you take this self-learning course from first.org to understand how the scoring system, which I gave an introduction right now, that could be other way that you could look at the scoring information. Let's come back to our slide set. So these are the items which I wanted to show as some samples as well as a demo on how to do this scoring. Let's continue further. Here I have put some references on where you can go and see. These are the list of the scoring system and the NVD database and the CWE, which I didn't get into too much in detail. CWE is a very useful database for people who are writing programs. They talk about what are the commonly made weaknesses or commonly made mistakes, the programming mistakes that like you may not be validating your input or the cross-site scripting, how it can happen, SQL injection, how it can happen. All those are explained in the CWA database. That is not vulnerabilities. They are the common mistakes that are in various software packages, and there is classification on how that can be. The good part with the CWA is they also have written there what is the method in which you can prevent them, what are the typical solution to prevent them. That's also one thing. And from the system architecture point of view, which I had put first, this is a playlist of some of the recordings on like my own recording of playlist from some or the other conferences which talk about more into the direction of hardware security, embedded system security, IoT security, and all those kind of topics are there. Even some of the recordings in that are on secure development lifecycle. So if any of you are interested in listening more listening to me, then you can look at these recording sessions. And these are the specifications I would look at. And the CVSS 4, this 4 version 4 is here, that talk about the public preview, what is upcoming, which will be adopted after some time. That good part which I liked there was they are also considering this critical infrastructure, not just from a software point of view, and safety as a concern for security. Those are all other points that are put in there. So this is what I had to say from the point of the session view. If there is any questions or anything else, we could listen. Thanks for your patient listening. I hope it was interesting.
Thank you very much, ma'am. It was very excellent presentation, very interesting. Thank you, ma'am. We have questions which has been posted in the chat box, and also some questions were asked during the registration process, ma'am.
Yes.
I'll first ask the questions which has been posted in the chat box.
Yes, ma'am.
First question, ma'am. Any industry accepted tool to generate a vulnerability report for website or mobile apps?
I don't say accepted tool in that sense. There are various tools which you can use for finding out vulnerabilities. I believe that's what you are asking. How do I find out vulnerabilities? From a mobile application point of view, the one tool which I have personally used is MobSF is one tool which I have used. If you can give the APK file of the mobile application, MobSF will run through that and will tell what issues are there. But the analysis, you have to do the analysis by yourself because the application is yours. MobSF is one. I don't say industry accepted because that is too much of a term of like, there's no forum to say this is accepted. But I would say which are commonly used. Okay, MobSF is one commonly used term for tool for mobile. And then you will also see many of the tools under the Kali Linux. Kali Linux has many tools there. And there are commercial tools also available to find out such kind of vulnerabilities, like Rapid7, Nessus. All those are tools which are commercially available. But if you are looking at free tools for understanding, playing around, I would recommend you to have a look at Kali Linux. Kali Linux inside has a lot of free tools available. You could look at many of them. They are ways in which you can find out. Typically web application, there are many easily available tools because they provide an endpoint where you can take it and run on that, right? So that like that's what I have come across is what I'm telling. Okay.
Okay, thank you, ma'am.
Like this Metasploit, that's another commonly one. That is part of the Kali Linux. You can take it up and use. Yeah.
Yes, ma'am. Thank you, ma'am. Next question, ma'am. Any specific standard tools or techniques to identify vulnerability existing in in-house designed under Web 3.0 and developed educational websites?
In-house designed. See, I don't differentiate between in-house design. I would look at them all as a web application which provides endpoints or which provides kind of HTTP or REST APIs, those kind of interfaces. So whether it is for the education purpose, whatever be the purpose in which you have written, the same web application tool is what you should look at, and then you should look at, because they are all of them are based on the same specifications of HTTP running over TLS HTTPS specifications. Since you asked this question, I would also recommend you to look at the best practices for securing web application from OWASP. OWASP is a place where there are many good practices that is put in. OWASP top 10 That is a place where many of the, where do I come? Yeah, here. Yeah. Open Web Application Security Project. OWASP is one place where you can go and look at. The top 10. Top 10 is these are the top 10 issues which are commonly made and commonly seen. And other point which you could look at it is from the HTTP, when you develop any HTTP based application, especially the headers, how to make them like cross-site scripting and SQL injection and those kind of things, how to prevent them. And there are good directions available on how to use the HTTP headers and HTTP good practices. So if you are developing any sort of web application, whether it is Web 3.0 you say, or whether you are talking about, but I do not know about very specifically of Web 3.0. That's not, but generically this is what I would recommend that you to look at the HTTP part as well as the OWASP top 10. Purpose may be education purpose. It doesn't matter why you are writing for finding out things. Like whoever asked the question, was that the intent of the?
Thank you, ma'am.
Yeah.
And the third question was relating to OWASP, but you have answered it. Thank you, ma'am. So next question from the participants who have registered.
Yeah.
Role of security on mobile phones, ma'am.
See, that is like my intention was not to cover those, but then there are good practices for from the mobile phone. There are, since you're talking mobile phone, there are two ways to look at it. One is your handset itself, and how do you manage the various applications in the handset? How do you give the permission? Do you provide a lock screen? What kind of locking mechanism you give? This is one way to look at it. Other way to look at it, if you look at the individual mobile application developed, if you are developing a mobile application, how do you take care of the security of the specific mobile application? There are two different ways in which you can look at them. From the handset or the instrument or the OS point of view, these are best practices to keep your system secure, apply your patches, like have your pin, have your locks. All those are best practices for securing your device itself. And whereas from an application development point, you could follow the application development best practices. And then we just before talked about MobSF and those kind of scanning tools which you can use for identifying the vulnerabilities in the typical application. So I would see them in two different angles. One is the mobile itself, other is individual applications.
Yeah, thank you, ma'am. Based on Qualys, Nessus or Rapid7 report, how to prioritize the exploitable vulnerabilities? Can you share examples for a real raw report?
I told about the CVSS score, right? In fact, these tools which are there, the Nessus, Rapid7, all of them, when they identify a vulnerability and then they classify it as high, critical, and the severity assigned, it is the same scoring system which we explained in the session that is used. So you should still refer back to the first.org scoring system and then map that scoring to the issue that are identified by one of those Qualys or Nexus or any of those scanning tools. In fact, all what we talked through in today's session, that is how you do your scoring prioritization, assign the number. I guess I covered it in detail on how to prioritize. That was a question, right?
Yes, ma'am.
Okay, so irrespective of the tool that you use, whether it is manual code review, find an issue, or one of the tools gave you an issue, the severity assignment is the same way in which the CVSS scoring, which is done across the accepted method, is the scoring system by first.org, and NVIDIA also uses the same. Even these tools also use the same. So if you see a number in any of this report, like I don't have a sample report ready in hand, even if I have, like they may be on actual products which I may not want to show. So, but if you look at some samples from the internet or something publicly available, if you look through the reports, they will tell that there is an issue, and they'll also put a severity number against that issue. That severity number is arrived based on these, based on the scoring system which I explained.
Okay, ma'am. Thank you. Next question. What are the challenges we face in securing private data, and what are the unknown mistakes that we make to facilitate the hacker to steal information?
That's quite a too broad a question. See, how do you protect private data? That was the first part of the question. Let me get a screen cleaned up. Okay. Give me a minute. Let me make some space on my screen here. Yeah, if you ask about, first is about protecting private data. There are various ways in which you can protect private data. There are data protection strategies and strategies and methods and techniques and tools available. Some of them could be your, if you are talking about, say, Windows, for example, there is something called your BitLocker kind of solutions. Okay, they are one way which you can use. Other way are like you use your disk encryption. There are disk drives. So those are all methods in which you can use for protecting private data. And there are solutions which are based on hardware assisted security, which I would recommend you to watch some of these webinar recordings on hardware assisted security. They talk much about into how do you protect data using the hardware mechanisms. Like solutions like a trusted platform module, secure elements, HSMs, all those kind of solutions is what you use for protecting private data. Like typically what you do is you encrypt the data with some key and then you protect the key. That is the method in which it is used. But then there will be performance implications because the large volume encryption will take time. Can we accelerate using the hardware? All those are the kind of ways in which you can protect your private data. And the second part of the question, what are the unknown mistakes that we make which will facilitate? Here, I would say it's a little bit vague to answer what are the unknown mistakes I make. Let us look at what are the known mistakes that we make, because unknown to some people could also mean that they are known to the industry. They like, though I have not seen it myself firsthand, the world has seen it. So those kind of known mistakes are the available, databases are available. The first place to look at if you are a programmer or developer or even somebody who is designing a system, I would say you go to CWE. That is a place called Common Weakness Enumeration. I'll just open that. Okay. Like if your intention is very much to, okay, I want to reduce weaknesses in my program. These are the kind of weakness classifications. What is, see, this list is there. If you go through them, they will tell what is the commonly made mistakes that the top 25 mistakes which are happening. So say out of band write, that is here. Improper neutralization of input. Memory, use after free. So these kind of issues are there. So if you open any of that, they will tell what are the other related issues that are coming in, and the even samples are there. Okay, demonstrative examples, how it can be. The code samples are there. How it can be. These kind of common mistakes are there. How programmers make those mistakes, and there are examples, CVs which are caused because of those kind of common mistakes that are made by the common weakness. That list is also available. And the best part which I would like you to look at is this potential mitigation. So what can you do to prevent them? Kind of information is also there. You can do static code analysis. The most usual static code, the lint-like tools, they will identify them. Or if you do these fuzz testing, powerful fuzz testing tools which are available, they also identify some. So if you are talking of what are the unknowns, make the known things to unknowns known by looking at these databases. And if you are writing programs in a very specific programming language, this database also gives you programming language based listing. Okay, it's not only about if you look at these mappings, you can look at them. They tell for this specific programming language what you care, what are the common mistakes those kind of, it is the same thing, but then they are organized and then given it in a very easy to consume manner. So I would recommend that you make use of this databases uh, rather than worrying about what is unknown unknowns. That is too difficult to reach there to the unknown unknown, but the, uh, expand on the known. And CW is a place where you can go to, and the CVE also I showed that are the known vulnerabilities on products which are available in the market, which I already shown as part of the presentation. But these databases, CWE is something which this is coming from an organization called MITRE, which they look at all these, make studies and then publish this kind and making it available to the interested parties. So that's what I would personally recommend. And also study the technologies which you are using for developing applications. What are the issues that are best practices for that specific technology? Like some people had asked about web application development. What are the best practices for that, and what are the commonly found issues there? Like database like OWASP, and then do it. That's what I have to say, ma'am, for that.
Yes, thank you, ma'am. One more question from the chat box. Ma'am, can you give a brief detail on CORS course as a web developer, and
Wow.
how can I prevent
think
such attacks?
it will be a bit too far to go there. That is about cross-origin resource sharing. Yeah. Ma'am, that's a little bit involved topic. Should I be
Okay.
like cross-origin resource sharing? I would still tell that even though I don't explain it right away, I would still request you to have a look at the OWASP, what they are talking about the course usage. OWASP talk about the best practices for setting these cross-origin resource sharing methods, and how can you test them. All those are shared in the like it will be a time taking a topic on its own. That's why I'm not getting into it. Okay, not for any other reason. But I would still look so recommend that you look at how to scrutinize those headers. How do we test for cross-origin resource sharing? And yeah, another place where you could look at for getting this information is Portsfigure. Portsfigure as a website, they keep publishing many of those issues which are commonly seen in the web applications. So these are the places I would like you to go and look at them, because it's a bit, the thing is, it's only one person interest, and I did not even give a context of HTTP headers itself. And we are talking of specific headers. Uh, I would still recommend that you look at the HTTP headers. What are the best practice for using, when to use what is the implication of using specific header values, and when you set something, and whether this cross-origin resource sharing is one among the headers that we are talking about, and how to use them. And the HTTP spec is W3C also might be giving you some more information on how you can use that. And OWASP gives information. In fact, I've gone through them myself, OWASP information on cross-origin resource sharing. That's what I would say. Or we will plan another session on that, how the
Yes.
HTTPS headers usage. Yeah.
And the participant has asked for the link, so you can later share that, ma'am. For how
Yeah,
to,
yeah.
yeah, sure.
Yeah, see, there are resources available in public domain which you could look at. Yeah, it's just that it is another topic of interest for a 1 minute answer, because we did not set a context for people to follow on the HTTP itself, right?
Okay, ma'am.
Or you
Thank you,
could
ma'am.
ask them to reach out to me. We'll speak separate outside. That's also fine. Yeah.
Thank you, ma'am. Thank you so much for your wonderful question answer session. I request any of the participants you want to ask the speaker any questions, you can just unmute yourself and ask.
Yeah, good question. Interesting questions.
Yes, ma'am. Any participants want to ask any questions? Sir, can we proceed for the vote of thanks, sir? Formal vote of thanks.
Yeah, okay. Dr. Komati can give the vote of thanks. No? If
Pardon,
Akila is
sir?
not there. No, if Akila is not, I mean, if Mythili is not there, Dr. Komati can give the vote.
Yes, sir. I request our Vice Chair, CSA Chennai Chapter, Gomati ma'am, to propose the vote of thanks.
Thank you, Dr. Akila, for giving
I
me
will
the
stop. I'll
opportunity.
stop sharing the screen. Yeah, thank you.
Yes, ma'am. Yeah. Thank you, Madam Minnie, for your valuable time spent with us today for an excellent, information sharing on patch management, especially that is more useful to us. Rather than, I mean, I would say that security, most of the students learn, availability, confidentiality. That's all we know. I mean, we teach them. But as such, you go beyond that, how the vulnerability goes into the probable risk and then the incidents and then how to measure the severity and what is the vectors and parameters involved, how to measure. Beautiful. So this is what I mean, and practically you are shown a demonstration also. So that would be definitely take the persons and students who are doing projects and research into that direction more depth. I think because I'm also that area I worked a lot of work I done, but still the patch management I just read and then I just left it. I didn't go further. So I think this is this is more interesting and more to investigate further, explore more on this. I think I will also lead into that so that you
Yeah,
have
thank
shown
you, ma'am.
me, shown me a new direction for me. On behalf of CSI, ACM, and IEEE CS chapters, I'd like to thank you for this wonderful evening for giving us on the security and vulnerabilities and then patch management. So, thank you so much. And I think the participants would have been enjoying it with their question and answers also. So further anything, I think you have given, a lot of open sources information also. They will maybe probably I and us will refer to that and come back to you. Thank you.
Yeah, thank you, ma'am. Thank you, Gomdi ma'am and Mohan sir and other organizers.
Yes.
It was indeed good for me too, because many a times I also have my own interest to propagate the message of security that okay, it is not just about developing the software, but also it is about developing in a secure manner. So it's also in my personal interest to do that, and thanks for providing that platform and the occasion and the opportunity and the audience for
Yeah, in future
doing
we
that.
will be
Yeah.
in touch with you for further, right, in this direction, ma'am.
Okay.
A lot
Security is
of
an ongoing topic.
Yes,
So
ma'am. Yeah,
there is no
evergreen topic.
every day.
Evergreen
And
topic. As long
and
as the
like see,
software,
I
as
also
long as
know
the
that I have to
hardware
learn
there.
a lot. That's why I'm also
Yeah.
studying. That's
Yeah. Thank you so much, ma'am.
thank you. Thanks
Thank
so
you.
much.
Thank you
Thank you,
very
sir.
much.
Yeah.
Very good.
Yeah.
Thank you, ma'am.
And
Okay.
thanks to all the audience. Thanks for your patient and attentive listening. I hope it was all useful. Like there were some LinkedIn posts and all. If you still have some questions or if you want some references, feel free to reach out to me. No problem. Okay. Thank you.
Thank
Thanks so
you.
much.
Thank you.
Thank you and good night, ma'am.
Yeah. Thank you. Very good.
Good night to all.
Yeah.
Okay.
Bye bye.
Bye.
Bye, sir.